Hi, everyone. Hey. Oh. Okay. No echo. All right. So let's see. Can I share video too? No, this not work. Okay. All right. So today is Wednesday, October 26th. Today we will talk about 5.1 angles. So I put out some 5.1 worksheets. If you need a copy, feel free. Yes. So do you receive my email? Mm-hmm. So this Friday we have a quiz 5 about 4.1 to 4.6. So I would say try to do your homework before you take the quiz so you can have practice, right? And the Monday you have homework 3.5 to 4.7 to do. So remember when you do your homework, you submit and then you can view details to see the homework solution. You know that, everybody? And then if you get wrong on some problem, look at the solution and see if you can understand. And then you can open another attempt to try the problem again. Or you can also print screen the questions and email to me. Yeah? If you have time during my office hours, you can come to my office. Or if you don't have time, email me. We can meet in the evenings virtually. Okay, everybody? Yes. So the review session is on Wednesday, 8 p.m. Okay, so go to TED Live. I hope you can do the practice exams before that Wednesday. So I told you last time, I showed you the student who did well, right? Did the practice exam. And I compared to you the practice exam and the actual exam, the type of questions are very similar. Do you remember that? So you use the practice exam as the study guide. Make sure you understand every problem, okay? And make sure you can remember the steps how to solve those problems. So I would say try to do the practice exam multiple times. So yeah, my previous students, he told me that he did the practice exam 3 times. The first time is 1 week before the exam, so he know what type of problem is gonna be on the exam, so he can review the notes for those topics. And then he did it second time, 2 days before the exam, just make sure he can remember the steps. And then he did the last time, the third time, the night before the actual exam, just to make sure. You know, math, you do it a lot, and then you can remember it, right? Okay, so that's our plan. Any questions? Okay, so if you have questions, remember not only you can send me an email, you can also post the questions on the website. So and then we can check it, and then I can answer the questions. So on the review session, yeah. I hope that you can ask me questions, then we can go over those problems together. Or if you have questions on the practice exam, then we can go over together. Okay, everybody? So Wednesday, 8 p.m. And I will also record the session. So if you cannot attend, you can watch the recording. And also, last night, I download all the recordings from Blackboard and then I post to YouTube. Okay, it's unlisted. Okay, so and then I post the link on the website. So hopefully now you can use your phone to click the link and then it's just YouTube, so it's easier to see it. Uh, there are 4 recordings with no sounds. That is because I was using this and sometimes this does not work, so that's why those 4 recordings we have no sounds. But other than that, should be okay. So our exam 2 is about 3.5 dividing polynomials up to 4.7. Okay, so if you missed some class, okay, please print out. Yeah, I have some extra copy of the notes 5.1. If you need a copy, feel free to come and get it. Yes. So it's good to have a good study habits for learning math. Okay. So it depends on your major. Maybe for some of you, Precalculus is your last class, math class, right? And maybe for some of you, you still need to go to Cal 1, Cal 2, Cal 3, linear, algebra, differential equations, probability, and statistics, right? So it's good to develop a good study habit. So my recommendation is print out the blank notes, okay? Print out the blank notes, and then take notes in class. Because when I write down the notes, this is the things I teach. So when you take notes, those are the things you learn, right? At some step, if you don't understand, you can write a question mark next to it. And then you can ask me, right? And you can write down more details or your understanding here, right? And then, yeah, so please take notes. And then after class, you review the notes and then do your homework, okay? So, because, yeah, so you review your notes and then kind of refresh your memory, what did you learn, and then you do the homework problems, and click how do I do, right? And then submit, you can view the solutions, and for the problem you got wrong, you can look through the solution and see if you can understand. If yes, then you can open a second attempt, right? You have unlimited attempts for your homework. And if you have questions, come to ask me. If you're not available during my office hours, email me. I'm happy to schedule a virtual meeting with you in the evening. Okay? So don't be afraid of asking for help. And we also have tutors in the tutoring service in the Office of Student Success in the basement of the Snyder Academic Center. Okay, so try our best. Try to understand every problem in class, okay? And on your homework, and then you prepare for the quiz, and then do the practice exam, make sure you understand it and remember all the steps, then you can be prepared for the exam. Okay, everybody? Mm-hmm. All right, so I have some 5.1 handouts. If you need a copy, yeah, come and grab it. Yeah. Okay, so last time we talked about 4.7, and we still have one last example we didn't do. So let's look at this example. Example 6. Okay, a cell site is a site where electronic communications equipment is placed in a cellular network for the use of mobile phones. The numbers Y of cell sites from 1985 through 2011 can be modeled by the following. Okay, where T represents the years. I think the years, with T equals to 5 corresponds to 1985. So then you can imagine T equal to 0 corresponds to what? Yeah. Oops. So T equal to 0 corresponds to 1980. Oh, attendance. Okay. So this is the 5.1 handout. Do you need a copy? Welcome. All right. Okay, so part A, use the model to find the number of cell sites in the year 1980, 1998, 2003, and 2006. Okay, so T equal to 0 corresponds to 1980. Then 1998 corresponds to T equals what? 18, right? Because you use it to subtract 1980, you get 18. Yes, everybody? Okay, how about 2003? That corresponds to t equals 23. Very good. And 2006 corresponds to t equals 26. Yes, awesome. Okay, and then keep going, right? So we want to find the number of cell sites. So which means we want to plug in the formula. So we can put y of 18, okay? We plug in t equals 18. So that is 269573. Yeah, we plug in this formula, right? We plug in t is 18 divided by 1 plus 985 e to the negative 0.308. Now times t. T is 18. All right. So everybody, let's do. Take out your calculator. Put this in your calculator. What do you get? So we plug in t equals 18. So try to enter everything in one line. So don't calculate the denominator first and then use it to divide it by that. Enter everything in one line. So put 269573 divided by, and then parentheses, 1 plus 985 times E. E is, you press second and then press the LN, right? That's the E. And then you input negative. So by the way, you know on your calculator, there is a button for negative, there is a button for subtraction. Yes, everybody? So we put negative, not the subtraction. The negative is at the bottom, it has the parentheses around it. Okay? And then you put 0.308 times 18. Close parentheses, okay? That's the exponent of the E. And then close another parentheses, that's the denominator. Then what do you get? What do you get on your calculator? So give me whole number. What do you get? Do you get 55557? Yes. Show me your calculator. Do you have the same number? Yes. Good. Good. Oh. Oh, because it needs a parentheses. Yeah, that's why I hope. Yeah, from now on, bring your calculator. It's very important to practice how to use your calculator. Please bring your calculator. Right. Okay. So that is y of 18. Okay, that corresponds to the year 1998. And then 2003 corresponds to y of 23. Right, everybody? So it's almost the same thing. So we copy it. And then we place. So we place the 18 by 23. Do you know your calculator, you can go up to the previous line? So please, go up to the previous line. And then replace 18 by 23. You don't need to type the whole thing again. you can go up to the line and then replace 18 by 23 and then enter. What do you get? Do you get 14764? Thank you. 7? Yes. Do you get this number? Yes. Please raise your hand. Okay, good. Yes. Awesome. And then 2006. Okay? So we plug in t equals 26. So y of 26 equals, so we copy it, right? Almost the same thing. And we multiply by 26. Okay? So go up to the previous line. Replace 23 by 26. So let's see. 9, 5, 7, 3, 9, 8, 5, 8. Oh, another parenthesis. Because this the first parenthesis goes to the exponent of the e. Second parenthesis goes to the number. Why is the same number? Okay. So the previous number, do you get 47 or 44? 44. Oh, so that's my mistake. See, I made mistake too. Okay. Aha, thank you. So check our work carefully. See, sometimes I make mistake too. Yeah. Okay, if you replace 3 by 6, what do you get? 203 023. Thank you. Right, everybody? Okay, so part A. We know the t, and then we plug in the function. We figure out the y. Okay, that's part A. Part B. Determine the year in which the number of cell sites reach 250,000. Okay, so part B is like the reverse order. We know the number of cell sites and we are looking for the time. So this direction is harder, right? Okay, let me use purple. So part B. We want to find the t such that the y equals 250,000. And the y is 269,573 over 1 plus 985 e to the negative 0.308 t. Yes, this is the y. We want to set it equals to 250,000. And then we want to solve for t. So far, so good, everybody? Okay, what do we do? Well, clear the denominator, right? So both sides multiply by the denominator. And then, so the left-hand side, this denominator and the denominator cancel. And the right-hand side, we have this guy multiplied by 1 plus 900. So left-hand side, so 269,573. Bless you. Right-hand side, 250,000. Multiply by this denominator. 1 plus 985 e to the negative 0.308 t. Okay? We want to solve for t. And remember, only use your calculator So don't use your calculator right now. Okay, only use your calculator at the last step. So right now, what do we need to do? How do we solve for t? We can distribute and combine the like terms, or we can divide it by that, right? So there are so many different ways to solve the equation, and then you compare which way is faster. Okay, so we both sides divided by that. This cancel. Then we have 269,573 over 250,000 equals 1 plus 9a5 e to the negative 0.308t. What do we do next? Subtract 1 on both sides. Right, everybody? Okay, so we have 269,573 over 250,000 subtract 1 equals 985 e to the negative 0.308t. So far, so good, everybody? What do we do next? Divided by 985. So divided by 985. Do you see? Now we isolate the exponential term. Okay, so 269,573 over 250,000. I know this is complicated. It's okay, just leave it like that. Okay, we will plug into the calculator later. Yes. So e to the negative 0.308t. How do we get rid of the e? ln. Oh, I ran out of space. I should write it smaller. So let me shrink it a little bit and move it here. Okay. Apply ln on both sides, right? After we isolate the exponential term. So ln of 269,573 over 250,000 minus 1 all over 985. And this is ln e to the negative 0.308t. You see, ln and e cancel. So this is negative 0.308t. What is t? The left-hand side. So 269,573 over 250,000 minus 1 plus 2 over 985 all divided by negative 0.308. So what do you get? Yes, this is the big expression. So enter that in your calculator, all in one line. So ln, okay, click the ln button, parentheses, and then put another parentheses, okay, a parentheses 269,573 divided by 250,000. Then subtract 1, parentheses, divided by 985, parentheses, divided by negative. Don't use the subtraction button, use the negative button. And then 0.308. What number do you get? You get 30.64. Yes. So we get 30.64. Okay? So it's about 31 years, right? And Remember, t equal to 0 corresponds to 1980, right, everybody? So 1980 plus 31 is what? 20, is it 11? Yeah. So in 2011, the number of cell size will reach 250,000. So far, so good, everybody? Questions? If I got 30.2, do I still round to 31 or I round to 30? Be careful. If we use 30, the number won't reach 250,000. Do you agree? It'll be less than 250,000. But the problem says you must reach 250,000. So you still use 31. Okay, everybody? Because you need to reach 250,000. Reach is like you must have not just equal, but greater or equal to, right? Greater or equal to. That's why your t should be greater or equal to this number. So therefore, if you get 30.2, you cannot pick 30. You must pick 31. Is that clear, everybody? Because you need to reach that number, 250,000. Right. Okay, so this is the example, last example in session 4.7. Any questions about 4.7? No? Okay. How about let's look at the practice exam? I kind of go questions. Oh, here because t equals to 5 corresponds to 1985. Yeah, that's so the problem gives us t equals 5 corresponds to 1985. So then because 5 and 0, the difference is 5. So 1985 minus 5 is 1980. Yeah. Okay, so let's look through the practice exam and see what type of problems is going to be on the exam. Okay, long division. This is in section 3.5, right? And then here, synthetic division. This is also in section 3.5, right, everybody? We learned long division and synthetic division. Okay, how about this problem? Remember, we use the log properties. Log can combine the sum into products and combine the difference into division, right? And then for the exponents, you can move it down in front. Okay, so problem 2, this is in section 4.5. Okay, here, I think we did this example in class, right? We did that? Okay, now you can, when you do the practice exam, you can do it again, right? We combine it into a single log. So you first move the coefficients on top of the exponents, and then you combine. If it's plus, that means this factor is in the numerator, inside the log, okay? And if it's minus, that means you put the factor in the denominator, right? And it's log of big parentheses. Okay, be careful, it's not log of something divided by log of something. It's only a single log, one log. Okay, everybody? And then this is like the opposite, right? ln, you can break the products into sum and break the quotient into subtraction. Therefore, you have ln of this guy, and then minus ln of this guy, and then minus ln of that guy, and you move the power down in front. Right, everybody? So this is section 4.5. Okay, complete factorization of p of x. This is in section 3.6. the rational root theorem, right? What do we do? Look at the factors of 3. They are plus or minus 1, plus or minus, plus 2, 3. And we look at factors of leading coefficient, which is 2. They are plus or minus 1, plus or minus 2. And then you use these factors of 3 divided by factors of 2. And then you get a list of rational numbers. Right, everybody? Then you plug into your polynomial, okay? So plug in each number in it and see whether that equals to 0. Okay? If you plug in it and get a 0, you find the root. That means if c is a root, means x minus c is a factor. Okay? Then you either use long division or synthetic division, right? Then you can get the remaining quadratic factor. So this is degree 3. You need the rational root theorem to find how many roots? Just one. Just one, okay? You plug in one number and you get 0, then you stop. You don't check the whole list. Is that clear, everybody? Just use the rational root theorem to find one root, okay? And then you use synthetic division or long division to get the quadratic factor. Then you can use quadratic. You remember the quadratic formula? So your answer, you might have 3 real roots, or maybe the other 2 roots are irrational, or maybe they are complex numbers. Okay, so you don't know. Use the quadratic formula to figure that out. Okay, so this is in section 3.6. Okay, how about this? Rational functions. This is in section 3.7. Right, everybody? Okay. First thing, this is easy. It's already factored. Okay, if you have like harder problems, you might need to factor the numerator and factor the denominator. It's like your last quiz. Remember your last quiz? You need to factor, right? And then, how do we find the x-intercept? Set the numerator equal to 0, right, everybody? How do we find the y-intercept? Plug in f of 0. Plug in x is 0 to find the y-intercept. And x-intercept and y-intercept, they are points. So you give me order pair parentheses, right, everybody? So not number, not equations, because equation means lines. Okay. Vertical asymptote. What do we do? Set the denominator equal to 0, right? And you also need to check the behavior when x approach to that number from the left and from the right. Yeah, everybody? So, yeah, so in this case, well, x, so you can factor out 3, you get x plus 6, so x equals minus 6, right? So, and then you let x goes to minus 6 from the right, and from the left, you look at what happened to the y. The y goes to infinity or minus infinity. Yes, everybody? And then horizontal asymptote. We let x goes to infinity and minus infinity. And then y behaves like what? We look at the dominant terms, right? Dominant term of the numerator is 7x. Dominant term of the denominator, 3x. So that's why, oh, do you see x cancel? We get 7 over 3. So y approaching to 7 over 3. So y equals 7 over 3 is the horizontal asymptote, right? And then after you know all this information, we can grab it. Remember, you put the dots, the x-intercept, put the dots, and the y-intercept, put the dots, and then vertical asymptote, left or right, top or bottom, then you put the little dots there. Okay, horizontal asymptote, Remember, you put a pair of dots because you don't know which one makes more sense. But when you connect all the dots together, you will pick the one that makes more sense to connect. Yeah, everybody? So this is in session 3.7. Okay. Here, domain. Remember log? We need the things inside the log to be what? Greater than 0. Yes. Square root. We need the things inside the square root. Inside the square root to be greater or equal to 0. Fractions. We need the denominator not equal to 0. So solve that and plus you graph it on the real number line and then write down the answer using interval notation. Okay, so this is domain. Okay. And then here, how do we solve equations involving exponential or log expressions? This is in session 4.6. Right, everybody? 4.6, we just learned it. Here, if we have the base are different, we just apply ln on both sides. Questions? Question 5. This is in general domain problems. So domain is I think maybe 4.1, 4.2, but in general domain problems, you remember the square root is a the a is greater than 0. So I think 4.1 and 4.2 something like yeah. So here apply ln and then bring the exponent down in front. And then you distribute. Move all the terms with x to the left hand side, all the terms without x on the right hand side, and then you can factor out the x and divide it by that and solve for x. Okay, everybody? So this is in session 4.6. If you only have one exponential expression, what do you do? Isolate the exponential term, right? Which means, what do we do? Add 5 and then divide by 8. Right, everybody? And then my recommendation is apply ln. Okay? Don't apply log base 3 because your calculator can only do ln or log. It cannot do log base 3. Okay, everybody? So just apply ln if you want to get rid of the exponential term. Okay, everybody? And so still in session 4.6, we talk about that. Okay, log. If you have two terms, you're gonna combine them first. So subtraction, you combine them, you get divide, right? And then, log base 3. Okay, then both sides raised to the power of 3. Okay, everybody? Yes. So this is in session 4.6. Okay. How about here? So in the practice exam, I asked you a log, okay? But you should prepare both log and exponential function, right? What's the parent function? So remember, e to the x, exponential function, right? Like that. And it passed through the key point 0, 1, and it has a horizontal asymptote. Right, everybody? And the log or ln is gonna be like that. This is 1, and it has a vertical asymptote. Yes. So remember these parent functions, and then the transformation is like what we learned before. Yeah, what's the first step? Left or right? Second. Reflect over the y-axis. Third. Reflect over the x-axis and stretch. And then the fourth one. Up and down. Right, everybody? But here, something new is you gotta write down the asymptotes, okay? Because I will ask you, what's the domain? What's the range? Do we have vertical asymptote or horizontal asymptotes? Okay, everybody? And remember, vertical asymptotes and horizontal asymptotes, they are lines. So you give me equations. Vertical lines, x equals a number. Right, everybody? Equation, x equals the number. Horizontal lines, y equals a number. Yes. And then here, guess what we just learned? Session 4.7, right? Application problems. And compound interest, remember the formula? A equals P times 1 plus R over N to the NT. Yes. Continuously. A equals P e to the RT. Okay, good. And this one, law of exponential growth. Then your formula is what? P of t is P0 e to the RT. Right? Everybody? This is P0 is the initial population, and R is like the growth rate. If your population increase, R is positive. If your population decrease, like radioactive decay, R is negative. Okay, everybody? Yes. So this is section 4.7. So your exams, you have similar type of problems. So now you know the topic. Make sure you understand every problem on the practice exam and remember the steps. Okay, everybody? They are computation problems. Right. Okay, and then, woohoo, we're done with algebra. Yeah? This is the 10th week. So we spent 10th week on algebra. Now, welcome to the second half of precalculus, which is trigonometry. So, okay. Yeah, trigonometry is kind of independent of algebra. Okay. So, right. Do you like draw pictures? Draw angles? Draw circles? Yeah? Okay. Oh, I still have one hand out of 5.1. You need it? Okay. Yeah. So, angles. Okay. All right. Yes. So I was looking at our schedule, and then this week is the 10th week, and then we start track, and we have 1 week. So it's like we have 6 weeks left, but 1 week is Thanksgiving and exam, so 5 weeks. We only have 5 weeks to cover track. Yes. So yeah, if you have a look at this, chapter 5 and 6 will be on your exam 3, and then we talk about chapter 7 and 8, and your final exam is cumulative. Okay, so we don't have an individual exam to test on chapter 7 and 8, so we just have the final exam. If you look at the schedule, the pace is quite fast. And our exam is on Monday. You only have a weekend to study everything. Well, it's quite challenging. Okay, so that's why I hope like you do your homework and collect the mistakes. It's good to look at the mistakes because if you don't have time to look through everything, because there's really a lot, then it's good to look at the mistake book and all the past practice exams and exams. Right. Okay. So let's start. All right. So okay, lines, rays, and segment. We can connect any two given points, A and B, in a flat plane with a collection of collinear points in three different ways. The points between A and B are called the line segments, AB. So we have the point A and B, line segment. It's just a line connecting them. And we can use this notation AB, and we put a line on top to denote this means a line segment. Okay. And then the points between A and B, and then extending past either A or B, but not both. Okay. Forever I call either ray AB or ray BA. So let's see. So we have A and B. Okay. We connect them, and then we go beyond B. And you can put an arrow to indicate it goes there forever. So this is the ray AB. And we can use the notation AB, and then we put an arrow. So this is a ray. Or if we have A here, B here, connect them, but we go to the A, extend in the A direction. Then this is the ray BA. Yeah. And we can put BA, and then we put this arrow. So far, so good. So segment, ray. Okay. Keep going. The points between A and B. And then we pass through both of them and go forever. So this is a line, AB. Or we can use the notation AB, and then we put the arrow on both directions. So we have segments, ray, and lines. So far, so good, everybody? Kind of easy, right? Okay, angle. An angle consists of either two rays or two segments in a plane with a common endpoint. Okay, so like this picture. Okay, this is an angle. The common endpoint is called the vertex. So this is the vertex. The two rays or segments are called the sides of the angle. So if I call this is the point A, this is like the point B, and this is point C, then this is the angle ABC. Or you can say this is the angle CBA. Or sometimes people just say this is the angle B. Yeah, just different notation for the angle. All right. And then the measure of an angle is a number associated with the amounts of rotation about the vertex required to rotate one side of the angle to the other side of the angle. Okay, so let's see here. This is the initial side. So initial side. Okay, it's the side for which the rotation begins. And then you imagine, okay, we rotate up to here. And then this is the terminal side. Okay, so we usually use this direction. So this is like if you draw the XY plane, this is really like the positive X direction. Okay, so this is like the initial side. And then our angle is going counterclockwise. Okay, so you can imagine this is the positive X direction, positive X axis direction. And then our angle, so usually we can use theta, Greek letter, alpha, beta, theta to denote angle. And it goes counterclockwise. Okay, counterclockwise. Okay. Okay, are you okay with counterclockwise and clockwise? Yeah? You look at your watch, your clock. Or If you use Apple phone, you might not see the clock. Okay, so the clock like that. So counterclockwise rotation has a positive measure. And then the clockwise rotation has a negative measure. So going counterclockwise is a positive. If the angle is going clockwise, then it has a negative measure. Yeah. Okay, and then coterminal angle. So coterminal angle have the same terminal side, but different in how many rotation around the circle we're taking to get to that side. Okay, so let's look at this picture. Let's say this is the x-axis, this is the y-axis, this is the origin. Okay, this is our initial side, and let's say this is the 30 degree. Okay, so you can see theta, the angle is 30 degree. That is right here. But you can imagine if we go across this and go one round, we have the same spot. We have the same terminal side. Do you know if we go one round, how many degrees are there for one round? 360. Yes. So that's why, 360 degree if we go one round. But ideally, you can go many rounds. Then you just add multiple copy of 360. Okay, everybody? So if you go 2 rounds, then 360 times 2. Right? So all this is called terminal angles. They have the same terminal side. Okay, but different in how many rotations. One rotation is 360 degrees. So far, so good, everybody? Okay, yes. So they are called terminal angles. Okay, the measures of coterminal angles differ by a multiple of 360. So, for example, 30 degree, right? If you add 360, that's 390 degree. So these two angles, they are coterminal. Right, everybody? Okay, so angles coterminal with given angle measure of theta. We have measure given by, so we already showed that, not just 30 degree, okay? Any angle theta, we add a multiple of 360 degree, okay? Yes, so that's one through rotation is 360 degree. Okay, next. Angles are named by stating a point on one side, the vertex point, and then a point on the other side, like our picture, right? Our picture A, B, C. Yeah? We say this is the angle A, B, C. Or we can use this notation. So this is like the angle A, B, C. Or we can use CBA. It represents the same angle. Or sometimes people just use B to denote. Okay? If the B is the only vertex of an angle. But if you have some picture like that, that's A, B, C, D, E, okay? Then you cannot say angle B because B is not a terminal, not a vertex of only one angle. It could be a lot of angles. It could be A, B, C. It could be A, B, D or C, B, E. One of the angles has terminal, have vertex theta. So far, so good, everybody? Okay. Angles are sometimes also named by the vertex points. If that vertex point is the only the only vertex of an angle, okay? Not like that case. All right. The most common units for measuring angles is called the degree. So on your calculator, you have degree mode and radian mode. Okay, so when you compute angles, make sure you're using the correct mode. So the symbol for the degree is this like small circle, right? The Babylonian decided that there are 360 degrees in one through rotation. A right angle is 1/4 of a through rotation. That's why 90 degrees. See? You know 90 degrees is this, right? A straight angle is 1/2 of a full rotation. That's why I measure 180 degree. So right angle is 90 degree, okay? And this is 180 degree. It's a straight angle. Okay, and then an angle between 0 and 90 degree is called an acute angle. So this is acute. All right. And an angle between 90 degree and 180 degree is called an obtuse angle. So like this is the obtuse angle. So far, so good, everybody? All right. Okay, I know today a lot of definitions. So that's why you can draw some pictures to help you understand. Greek letters are often used to denote the measure of an angle. So alpha, do you know this Greek letter? Alpha, beta, gamma, delta, phi, beta, psi. Okay? Greek letters. Okay. Strictly speaking, you should not mix up the name of an angle with its measure. If you are talking about an angle A, or use this notation, you should say the measure of the angle A is 85 degrees, or that the measure M of the angle A is 85 degrees, or the measure, so M denotes for the measure is 85 degrees. In reality, people usually just say A equals 85 degrees. Okay? Yeah. All right, and then complementary and supplementary angles. Complementary angles have the measure that add up to 90 degrees. So, for example, 90 degrees. So let's say alpha is here, beta is here. So alpha and beta, they are complementary angles. So they add up to 90 degrees. Okay. Supplementary angle, if they add up to 180 degrees. So now if this is alpha, this is beta, alpha plus beta is 180 degrees. Okay? And so this is complementary angles. This is supplementary angles. What is the supplementary angle of 50 degrees? 130. Yes, right. Good. Okay. So this is some exercise. Let's do some exercise. Find the complements and supplements of an angle measuring 38. Write down your answer. What's complements? What's supplements? How do you find the complements? We use 90, right? Subtract 38, that is 52. Yeah, so that is the complement. How about supplement? 180 minus 38, which is 142. Yes. Right, everybody? Okay, and then number 2, find the theta. In the picture here. So BAD is 22. What is theta? 68. Yes. 90 minus 22 is 68. Very good. And find the alpha below. So this is 157.3. You start with what angle? 180 or 90? 180 minus 157.3. What do you get? 22.7. Yes, awesome. Okay, this one, it has an x. Okay, so this angle is 2x minus 2. This angle is x minus 1. When you add them up, you get 180. Good. See? 2x minus 2 plus x minus 1 is 180. Okay, maybe let's do the angle later. How do we solve for x? Combine the like terms. How many x on your left-hand side? 3x. And do you see the minus 2 and minus 1 together? -3. If we move the -3 to the other side, we get what? 183. Yes? 183. What's x? 61. Yes. And then you can put the degree symbol here. You don't have to carry the degree symbol in the area or line. You can just put it at the end. So far, so good, everybody? Okay. Now let's look at this one. Find the measure of the smaller angle formed between the hands of a clock, reading 238. So 238. Okay, you have a clock. You have 12 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Okay. So 238. So this is the 2. Okay. And the hour hand is like here. 38. You know, the 8 represents like 40. Yeah. 38 means it's a little bit smaller than that. Right? So we have the hour hand and the minute hand. 38 right here. Okay. And we want to find the smaller angle between them. Right, everybody? Okay, so how do we do that? So 1 hour. One full rotation is how many degrees? 360. How many hours total in a clock? 12. So 1 hour is like 360 divided by 12. This is 30 degrees. Do you agree? How about 1 minute? How many minutes in 1 hour? 60. 360 over 60. We get 6 degrees for 1 minute. Okay? So let's look at the angle made with the 12. This is like the initial side. This is like the terminal side. Let's figure out the angle of the minute hand and then figure out the angle of the hour hand. Use this angle minus that angle. Okay? How about let's continue next time? Okay, let's continue on Friday. Okay. Have a nice day. So do your homework. Quiz is on Friday. If you have questions, email me. Bye.